Hello. In this demonstration, I will evaluate tool Microsoft Log Parser on one idea, that is Windows event log record of everything that happens on the machine, and the Log Parser let you queries those events using SQL, the same language used for databases. The story I chose is a break-in. Someone got into a computer and the event log silently record the traces. My job in the demo is to play investigator, take a log file you have never seen from your system, and use queries to reconstruct what the intruder did step by step. The reconstruction is the demo here. Why this is maps to Murphey's paper. Murphey's whole paper is about a 4-stage pipeline, that is recover, repair, validate, and collate. Since I am using publicly available event log, I demonstrate last two stages, that is validate and collate. Validate in the sense is this log file actually readable and intact. Collate mean pull all the scattered events into one ordered timeline I can read. Here I have installed Log Parser CLI version and Log Parser Lizard, that is GUI version, alongside with Sysmon. Sysmon will help to pass all logs to event logs even in server reboot. Here for demonstration I used Log Parser Lizard version. You can clearly see the GUI version and the CLI version. In here you can see what are the differences between each tools. Keynotes are like both are free version, but the key notes are in CLI version it can output CSV, TSV, XML, data grid, chart, syslog, or to even to databases. In GUI, it has built-in charts, pivot tables, and PDF and reports. These are some of the areas we can use these tools in digital forensic. These all are identified with event IDs. It can be used to identify failed brute force logons, successful logon type, and process and command execution, and to identify lateral movement signals, and even to investigate forensics. These are some of the limitations in Log Parser. Key highlight, that is Log Parser is no longer maintains and no official support from the Microsoft, and this does not go in line with non-native tools like Sysmon and other tools. The main concern here is like fields are read positionally, not by name, so this can lead easy to get wrong because the fields are not identified with name but with even ID and position. This is how the demo will proceed. First discover, read the log structure, and then foothold, finding the malicious event and ID, then execute, process, run, and identify, then and collate, that is order events into one timeline. Here I am not going to create an incident but to use sample attack publicly available and show how to find what is exactly happened with the incident with Log Parser querying. By the end, you can take unknown event log and reconstruct what happened using SQL with Log Parser. These are some of the reference I used to create this demo. We will go with the demo now. Here as the first step, I will create the I will read the log file, but before that I will show you where I have taken this public example. This is where I have got the example, and I download the file and create a directory on the C drive, and copy the file here. And this is the intrusion file that I am going to check with LogParser CLI version. When I run it, here I uses first reading the log files LogParser query and read the saved Windows log event file, and this will display 5 event records with 4 selected fields like event ID, time generated, string, message from. But since it is hard to check and what are the events happen, I will go with the CLI version. This is the query for the CLI version, and I will execute it again. Now in the row 3 you can see the event happen date and the integrity level. Process was running with the elevated administrator token, and what is the directory that it was run, and parent ID and process ID. You can see some useful information. As the second step, we check the foothold, that is the break-in. This query extract a timeline of sysmon event ID 18 name pipe connection event from the intrusion evtx file saved in C directory. What it does is actually ask the log did anything connect to a name pipe. Event 18 is sysmon's pipe connected. Token string 4 and pulls out slot 4, the pipe name, and the slot 5, the process. When I execute this query, this is the output I am getting. What we got is one row, pipe name, this value, and the image type is system, and this time frame. This is a system level pipe with a random 32 hex name. Is the signature of a remote shell. So this is the intruder's entry point actually. This is step 3, B2, the execution. What the actual foothold run. This query suggests what it does. Ask what program did the shell launch, and the event one is process creation. So we have got the events, which of the programs the intruder run, the PowerShell command, and what are the directories that the execution was happen. Now, this will confirm these were spawned by the pipe-based remote shell, not a real user. This is the intruder doing things. This query helps an investigator to determine what programs were executed and when each program run, which command line arguments were used, and the working directory for each processes, whether any suspicious tool or commands were executed. This is the step 4. This is beat 3 reconstruction. This query says the evtx file for process creation event where who am I execution was executed, then shows when it happened, and the command line is used. What this query does is same as B2, but filter to only to who am I process. The classic who am I, what can I reach, reconciliation step. This is where the intruder actually looking around to do something. In the step 5, let's do validate and collate together. This highlighted query counts the total number of event records inside the saved Windows event log file. That is 7 here. And the second query, this one. The second query, this query creates a combined timeline of selected Sysmon events from intrusion evtx file. What it does actually, instead of 3 separated question, pull events 1, 3 and 18 together and sort by time. So what we get here is the scattered traces became one noded story, pipe connects, process run, and who am I. This is actually Murphy's unified chronological view. The deliverable real this is the deliverable real investigator handover. As step 6, let's visualize the diagram. This query summarizes the event log by showing how many times each event ID appears in the evtx file. So then I will show you how we can get a graph from this value. Open grid and we have to drag and drop this event and ID for row area and data area. This should be other way around. ID and events. So the events are in the summary type with count, so I'm changing to sum so you can clearly get an idea. So what the chart shows is It's actually a bar chart of how many events of each type are in the intrusion log. The horizontal axis is the event ID, the x-axis, and the bar height is the count of that event. So the event 1, so event ID 1 has 3 events, and the event ID 10 has 2 events, and the event ID 3 has 1 event, and event ID 18 has 1 event. Totally the total 7 event has happened in this scenario. So as finals, the each query producer constraint or artifact. In here, the malicious name pipe. This is the pipe name. This is owned by the system process. This happened at this time. A system level pipe with a random 32x name. It is not something Windows or normal software create. So this is the evidence of remote shell foothold, and the process is spawned from the shell event. Let's use this one again. Okay, now you can see the processes spawned from the shell. This process creation events host current directory reference pipe shell. That string tries the spawn process back to the name pipe shell from exhibit 1. This is the evidence that the foothold was used to execute a code. In here, the reconstruct command, who am I all here, that is run by the same shell context. This is the evidence of attacker activity on the host, someone orienting themselves, not a legitimate user, login into do work. Then we get the count of this event. This is the evidence that log itself is intact and other exhibits are trustworthy, not artifacts of a corrupted file. This is a collated timeline. That's event 18, 1 and 3 ordered by time. This is the evidence of sequence. Sequence that connect pipes connect process run. Who am I all within the same brief window.